All right, pre-cal 10, here comes your lesson on perfect squares, perfect cubes, and how we get roots and their relationship. Now, we've already talked about this a little bit, but we're going to jump into how we can simplify roots as well. So remember that if you have a perfect square, 1, 4, 9, 16, 25, 36, so on and so forth, what makes these perfect squares? Well, they all have two identical roots. So that is the definition of a perfect square. It is a number with two identical roots. That's what you need, or sorry, identical factors. You need two identical factors. Those two factors give you the root of that number. A cube root is almost exactly the same, except they have three identical factors. So we still have one, but now our numbers go up faster because 8 is 2 times 2 times 2. 27 is 3 times 3 times 3. So you can see the perfect cubes go up much faster. 125 is 5 times 5 times 5, so on and so forth. This time we need three identical factors. So that is how the index increases. Square root, cube root, fourth root, fifth root, right? Two identical factors, three identical factors, 4, 5, and it can continue up and up and up. You can have, 30-second roots, but we don't really talk about those. Those numbers get absurd. So how do we figure out if a number is a perfect square? Now, 64, you'll be like, oh, it's easy. It's just 8 times 8, two identical factors. Sure. But if you didn't know that, let's just say you're like, okay, well, 2 times 32, 2 times 16, 4 times 4, 2 times 2, 2 times 2. You're looking for two groups of factors. So you have 1, 2. So I put a 2 here, a 2 here. 1, 2. Put a 2 here and a 2 here. 1, 2. Oh, would you look at that? A 2 here and a 2 here. I have exactly two groups. And those groups are 8 and 8, which means the square root of 64 is 8. So that's how we go about it. 441, you might be looking at it going, is that a perfect square? Well, I don't know. 4 plus 4 is 8, plus 1 is 9, so I can divide by 3. 3 goes into 4 once, 1 remainder. 3 goes into 14 4 times, 2 remainder. 3 goes into 21 7 times. Oh man, can I divide 147? Well, divisibility rules. 1 plus 4 is 5, plus 7 is 12. So yes, I can divide by 3 again. 3 goes into 14 4 times, 2 remainder. 49. And then 49 is 7 times 7. So look at your two groups. 3, 3, 7, 7. Do you have two identical groups? You do. 21 and 21. So the square root of 441 is 21. So you're looking for two identical factors, even if you have a bunch of small factors. If you can put them into two groups, you're good to go. Perfect cubes are the same. So 125 is 5 times 25, which is 5 times 5. How many identical factors do you have? 3. So the cube root of 125 is 5. 729, a little bit harder to divide, but again, divisibility rules. 7 plus 2 is 9, plus 9 is 18. I can divide by 3. 3 goes into 7 twice, 1 remainder. 3 goes into 4. 12 4 times, 3 goes into 9, 3. I can divide by 3. I get 81. I can divide 81 by 9 and 9. Now I strategically chose those, but I'm looking for three groups. That would only give me two groups, right? 3, 9, 3, 9. So let's keep dividing. 3, 3, 3, 3. So now you look, you got 1, 2, 1, 2, 1, 2. That's three groups because now it's a perfect cube. So I'm looking for three groups of identical factors. And I have 3 times 3, 3 times 3, 3 times 3, which means 9 times 9 times 9. So it means the cube root of 729 is 9. If you can make three groups that all contain the same factor, you have a perfect cube. Okay, now, roots are the inverse of cubes. So, as I mentioned earlier, that is a square root. That is a cube root. That is a fourth root. That is a fifth root. This little number is what we call the index. and it determines how many factors you need in order to be a perfect square, perfect cube, perfect fourth root, perfect fifth root. You need that many identical factors. So if we look at the square roots, right, the two identical factors under the root, so I just want you to look at it a different way. The square root of 64 is equal to the square root of 8 times 8. Since you have 2 underneath, it becomes 1 on the outside. So I said, Chandler and Spice Girls, Google it, when 2 become 1. So 225, well, that was 5, and then we get 45, which is 5 and 9, which is 3 and 3. So if you think about that, under the root, instead of 225, you'd have 3 times 3 times 5 times 5, which means under the root you would have 15 times 15. 2 of them come out as 1. So how does this look then with cube roots? Well, it just means that underneath the cube root now, we need 3 identical factors, not 2. So this isn't always as easy to get, but if you break your number down here, you can see, well, I have the cube root of 64 is 2 times 2 times 4 times 4, but 2 times 2 is 4. So you have 3 identical factors. They come out as 1. And then for 216, 2, and you get 108, and then 2 and 54, and then 6 and 9, and yes, my factoring is quick, but you'll get there too. Just all the way down to primes, because now I have the cube root of 2 times 2 times 2 times 3 times 3 times 3. And what I'm looking for is 3 identical factors. And in this case, I would pair up my 2's and my 3's. So I have 6 times 6 times 6. 3 comes out as 1. Now in the next section, you're going to see how we simplify a root when we don't have perfect scenarios. So root indexes cancel with exponents. What I mean by this is squares and square roots zip and unzip. I got a video on this in my grade 9 if you want to watch, but they undo each other. And the reason being is, if you look at this logic, root 64 equals 8. Well, 64 is 8 squared, which means that if that's true, then the root and the squared must cancel each other out. And 32, well, 32 is 2 times 16, which is 2 times 8, which is 2 times 4, which is 2 times 2. 1, 2, 3, 4, 5. So 32 is the fifth root of 2 to the 5. The root cancels with the exponent. The fifth root of 32 is just 2. That's a cool little piece to it. Okay, the square root of x squared is x. The cube root of x cubed is x. The fourth root of x to the 4 is x. The root and the same exponent, the root index and the same exponent cancel each other out. So again, this stuff can get a little bit confusing, so look for some shorts. I'll make some as quickly as I can, but watch this video again if you want to make sense of squares, cubes, and roots. Our next video is irrational numbers and how we can work with them. So squares, cubes, fourths that we can't, that aren't perfect. We can't make them into a whole number. So we'll go from there next. Enjoy, and see you soon.